Water efficiency for LEED version 3, 2009. Water efficiency is an important category of LEED because it addresses that water is a depleting resources. Lake Mead, for example, supplies water to millions of people and has a 50% chance of running dry by 2021. This is according to the study from the Scripps Institution of Oceanography, a very credible resource. Water efficient strategies have economic benefits as well, since it cuts costs on the amount of energy, therefore money, to treat, pump, heat, cool, and distribute water to our different building areas. Water heating, for example, in commercial buildings accounts for nearly 15% of total building energy use. Approximately 138 billion BTUs of energy is required to process this water annually, and 98% of which is used to heat the water. So this is where you can see solar water heating have a good return on investment for something like a hotel or student housing where a lot of water is used. So it's important to implement water efficient efforts. So water savings really does equal energy savings. Remember to keep thinking about synergies within the LEED rating system. That is something that is tested in the exam. So you reduce water usage in building, you have energy cost savings, lower water and sewage fees, and it lowers your energy to heat and pump the water. As we saw, heating the water is a huge cost. Next slide. Tankless or on-demand water heaters are one method that you can use for water efficiency. It heats the water on demand and can create 40% energy savings. This is an example of an instant flow tankless water heater. Potable water is really what this LEED category is trying to protect. That's our drinking water. So there's lots of alternatives we'll look at that can replace what our potable water is currently used for, such as toilet flushing, irrigation, HVAC, chiller makeup water, and janitorial type of uses. For implementing these type of alternative strategies, it's important to understand different resources of water, such as reusing gray water. Gray water is defined by the Uniform Plumbing Code as untreated household wastewater which has not come in contact with toilet waste. This includes bathtubs, showers, bathroom sinks, and laundry water. Next slide. You need to check with your local jurisdiction of what exactly is included as defined as gray water, but typically it does not include kitchen sinks and dishwashers. It's very hard to process organic matter in raw foods. Graywater Re-use can be used for landscaping or flushing toilets, but you do need to check with your local codes. This diagram includes a dishwasher, which typically would not be included, but definitely your laundry and your showers can go down to a pre-treatment type of system. And then for landscaping, you don't need very many levels of filtration before you reuse that water. If it was coming back into the building, you would have to get into a more complex system, often using even UV to treat the water. For the LEED category, these water efficient categories are looking to reduce the quantity of water needed for a building, especially reducing the potable water use, protecting our aquifers, so that we're looking at recharging our natural systems, and reducing the treatment of wastewater conveyance, especially from potable water. So even treating wastewater on site and other innovative strategies. LEED version 3, 2009 introduced a water efficiency prerequisite for water use reduction to be 20% less than the Energy Policy Act. So that's a requirement for every building now. You can see water efficient landscaping is more heavily weighted, 2 to 4 points available. Innovative wastewater technologies is also a little bit more heavily weighted, not as much, as 2 points available. Water use reduction is 2 to 4 points available depending on how much water, potable water, is being conserved compared to the Energy Policy Act. Process water use reduction only applies to schools. The water efficiency prerequisite 1, water use reduction, is required for every building type, new construction, schools, and core and shell, and the LEED new construction major renovation rating system. It requires to use 20% less water than the water use baseline calculated for the building. This is not including irrigation. That's in the first credit coming up next. The baseline standard you need to memorize for the exam is the Energy Policy Act. This sets the baseline of conventional fixtures so you compare against to show that you're meeting that efficiency requirement. WaterSense is a really good third-party resource to compare systems, because when you're looking at water-efficient fixtures, you want to make sure they're still functioning and have that pressure to get everything taken care of. It's a partnership program with the EPA and those different vendors with water-efficient systems. And those fixtures that we include for this prerequisite are water closets, urinals, lavatories, showers, kitchen sinks, and pre-rinse valves. Fixtures you don't include are steam cookers, dishwashers, commercial ice makers, and clothes washers. The benefits of water reduction include reduced building operating costs, therefore the reduction in energy-related pollution such as your carbon footprint, more stable municipal taxes and water rates if they don't have to expand their current municipal systems, and you're decreasing the amount of water withdrawn from rivers, streams, and aquifers. Related credits include stormwater design, and this could be if you're harvesting rainwater for toilet flushing, that therefore helps with stormwater management, or the water then can be used for water efficient landscaping. Innovative wastewater technologies is directly related since you're reducing the amount of potable water used for toilet flushing and urinals in that case. And water use reduction is building off this prerequisite. Processed water could include using makeup water for chillers with non-potable sources. Fundamental commissioning, enhanced commissioning, and measurement verification, meaning that you have to still commission these systems depending on what you're implementing. Rainwater harvesting would definitely be something that you want to commission. There are regional variations where there's a lot of rainwater per year. That's definitely a system you'd want to consider, but local building and health codes differ on how you can use these alternative water methods. In Portland, it wasn't until recently, in the last about 5 to 6 years, that we could actually bring treated rainwater into our building for toilet flushing. And those codes are continuing to evolve to allow for more sustainable design in our buildings. For operations and maintenance, after the building is constructed, you want to consider installing submetering for water consumption and integrate electronic data logging. This is kind of put in place during commissioning, and you want to educate your facility staff on how to maintain it and possibly have an integrated control systems to maintain it more easily. Special cleaning and maintenance may be required for something like a rainwater harvesting type of system, or maybe wastewater treatments that are on site. So you want to have a preventative maintenance program to check for leaks as well. For the calculations, you need to understand what a baseline case is. This is setting all the water fixtures to their conventional levels set by the Energy Policy Act baseline. And the water reduction percentage is based on total water consumption, not how much more efficient those individual fixtures are. So this has to do with your full-time equivalent occupants and how the building is being used. So you need to break those full-time equivalent occupants up into their fixture usage groups. So if everyone uses the same standard fixtures throughout the building, use one fixture usage group. And if different groups use different fixtures, such as retail customers on one floor and office workers on the upper stories, you need to use different fixture usage groups. For private fixtures that are only intended for individuals or a family, that's in a different category called private fixtures. For the calculations, the calculated water use reduction is calculated by dividing the design case and the baseline case. And the water use calculation is based on water use, not fixture counts. And when using fixture usage groups, calculate the fixtures being used and who they serve. Use the private fixtures for any form of permanent or temporary residence, such as apartments or hotels. For the exam, it's important to memorize the Energy Policy Act as a standard that sets a baseline for the water use reduction and other water efficiency credits in this category. And other additional resources you can check out are the International Association of Plumbing and Mechanical Officials publication, International Code Council, International Plumbing Code, and the American Works Association. WaterWise has a lot of really great resources. It's kind of a water efficiency fixture clearinghouse. There's a link for your reference. That's not needed for the exam. You won't be tested on specific fixture types. It's really about understanding overall calculations and concepts in order to meet the LEED criteria. Here are your default fixture uses by occupancy type. You can see a difference in water closet usage from females to males, and also urinals, obviously only applying to males. You have to take into consideration your lavatory faucets and showers where applicable, and showers where applicable. Kitchen sinks are also counted. And then you actually do a calculation of all these combined. You want to consider the full-time equivalency, occupancy, and if they're transients, not using the building all the time. Here is a snapshot of water savings assessments by strategy. You can see down the line, like number 6, low flow showers have high annual water consumption and also good annual water utility savings and high percent savings over baseline case. A combination of all these strategies has a best case scenario at the end. So looking at dual flush toilets, low flow urinals, automatic sensors and lavatories, low flow kitchen sinks, and showers. Combining them all has the best result.